Hello everyone. Today I am going to tell you an easiest way of plotting or graphing a piecewise defined function. In my previous lecture I have told you how you can evaluate a piecewise defined function. For that you can refer to the information link above. And today we are going to discuss how you can graph a piecewise defined function in easiest way ever. So here we have a function that is h of x equals to 2 if x is less than or equal to 1 and h of x is equals to x if x is greater than 1. So keep this in mind that h of x is basically divided into two pieces. If I say this piece is g of x and this piece is f of x, then it will be easier for you to understand. We will plot this g of x on this graph and this f of x on this graph, and h of x, that is the combination of this g of x and f of x, that is h of x, on this graph. So we have basically split the h of x into two graphs so that you can have the clear information or clear understanding of how you can graph or plot the piecewise defined function. So first of all we will plot h of x is equals to 2. So keeping aside this domain or this limitation, we will just plot h of x is equal to 2. This h of x is equal to 2, that I also say g of x, you can also write it as, I will plot it with the purple color, so y is equals to 2. This h of x is equals to 2, you can also write it as y is equals to 2 for your ease. It shows that the value of y will be 2 on every value of x. Or you can say on any value of x, whether it's 0, whether it's 8, whether it's 10, whatever the value of x is, the y will always remain 2. So in order to plot it, let's see what I have to do. I just need to plot y is equals to 2. So this is the line that is showing y is equals to 2. But here there is no limitation of the domain, as both the functions, that is g of x and f of x, have different domains, but currently I have not applied the domains on these individual functions. I will apply the domain on the function h of x. First you need to understand it how you can plot. Now we will move towards f of x, that is h of x is equals to x. So you can say that this function h of x is equals to x. And you can also write it as y is equals to x, just like we have written y is equals to 2 in here. So y is equals to x means if y is 1, x will also be 1. If y is 2, x will also be 2. And if y is 0, then x will also be 0. It means x and y are having the same values. So the graph of y is equals to x or x equals to y will be a straight line. So that straight line will pass through origin. So I'll start from here and it will extend on both sides. And if you see the points, you can see here that this point will be 2 and 2, that is if x is 2, y will also be 2. This point is 4 and 4, that is if x is 4, the y will also be 4, and so on. So this is for y is equals to x. Here also there is no restriction of the domain. Domain means the value of x. Now we are going to plot both these functions on one single graph, and this graph will be of h of x. So now I am going to combine both of these functions that are you can say both the pieces of the function h of x. One piece is y is equals to 2, and if I say one piece is y is equals to 2 and the other piece is y is equals to x. So let's plot it on the graph. How we will do it? We need to keep this in mind that both of these pieces have their different domains. Like this is the different domain and this is the different domain. That is the value of x on which that function is going to be plotted. So for y is equals to 2, we have to take only the portion that is less than and equal to 1. X is less than and equal to 1. So we have to check from where we have to move on. So if I point it on this, it means we have to take this portion where x is less than and equal to 1. It means 1 will also be included. So let's plot it on the final graph. What we have to do is we have to start from this point, because here x is equals to 1 and in our domain we have x is less than and equal to 1, and we will go towards left, and so on. And keep this in mind, this circle will be filled. That shows that the point x is equals to 1 will also be included. So this function is for x is less than and equal to 1. So the next is h of x is equals to x. Now let's see what portion of the second piece of the function h of x will be included in the final function h of x. In this we have the domain if x is greater than 1. It means we have to take only that portion of the graph that is in which the value of x is greater than 1. And keep this in mind, here the x value of x is not included. It means the portion that we want here will be this portion, and we will discard the rest of the portion. So let's draw it on the final graph so that you can see it easily. So we have to take which one? We have to take the portion that is x in which x is greater than 1. So this will be the line, and keep this in mind, x is equals to 1 will not be included. So I have just put a hollow circle here, and it will move so on. So this basically is for the domain of x greater than 1. Now this is the final graph of the function h of x. So the very important things here are the domain value. Although the functions itself have the different plot, but the plot that will be in given h of x will mainly depends on the domain values, that is the value of x on which these functions are defined in h of x. So this final graph is showing the graph of h of x. So this is how you can plot piecewise defined function. That's all from today's lecture. Thank you.